So hello everyone, good afternoon, and I hope you all have a very good lunch. My name is James Hoyd. I look after the system simulation capability for Wind River, and I'm based in a very snowy London today. So I'm sorry, and I wish I can be physically with you today. This is a great event today. Anyway, I've been enjoying the presentation from all the speakers this morning, so thank you very much for sharing and let me learn about how GR740 is being used in many great projects. So now is my turn to return our experience. So let me just turn my page. So the agenda for my talk is ever so simple. Just start with a very quick introduction. Then I'll spend a little bit of time talk about the simulation with determinism. What do we mean by that, and how is it being useful in our case? And also, then I want to spend majority of the time to show you how it actually works, so that it's much more concrete in your mind how this Simics is working, and hopefully you can learn something from there too. So very quickly, Wind River is a software company. We are well known about our core business, which is real-time operating system. Our VX work have been deployed to mission in the Mars, and also just been to the moon and then back to the Earth a couple of days ago. And many of our operating system have been configured and enabling satellite to orbit many different planets. And we have been also developing a hypervisor, as well as we have our own version of Linux. If you don't know, they all are designed. They all designed for mission critical application, and where software could not fail. However, we seldom shared and talks about how we test them, and most of the time, testing is more costly than building the code in the first place. So from our experience, is a ratio of 100x. So a line of code in production code takes 100 lines of test code that we need to build. So today, I'd like to share with you about 10 years ago, we started our own digital transformation, which is a big part of it is to leverage system simulation to make our tests earlier, sometime before silicon, and also faster. We can run parallel tests. We can use checkpoint and hyper simulation to run faster than real time, and makes it more cost efficient to run tests. So that is our mission, and it is because we need to move out from how we test our code like 1987 when we first launched our VX work. And we need to make our working with software more like the year 2022 or maybe 2023 in next couple of weeks' time. So this is a quick introduction, and about determinism in simulation is all about consistency. So we want to have consistent result anytime, anywhere. So Simics have been well before we start to use Simics. It have already started in Stockholm and with a company called Virtual Tech 23 years ago, and it's still a growing platform. Simics is a standalone application that runs on generic 64-bit PC. Modern PC runs Windows or Linux, and it's here to provide a deterministic virtualized hardware platform. So if we can imagine that Simics is provide this environment to allow us to write and instantiate different hardware models. So it's a protective environment that protects all these different hardware models. For example, in terms of GR740 is the Leon 4 processor, is the SPI controller, is the PCI controller, is the timer itself. These are different hardware models that Simics protect and isolate from the environment that is running in, and to support the software that you want to run on top of it. So that is the goal of Simics, is to provide this platform to have different models which can be developed by different company. When we develop our own models, and you can develop your own model to coexist on this Simics environment in order to support software to work. So on the right-hand side, I'm trying to illustrate in more detail that on the host hardware and the host operating system, Windows or Linux, we have this Simics environment that can have two simulator hardware, and it can run its own operating system, and on top running different application code. These virtualized hardware, it can be GR740, it can be an ARM model, it can be PowerPC or Intel processor. And more to that is these hardware are not isolated. They can be connected inside Simics with virtual network as well, so that they form a complete system. So that is, from a very high level, what Simics environment looks like. So one important thing about running simulation virtual hardware is to use the same production code as on the hardware. So the same production code that you're going to flash and test on the real hardware runs on this simulator. There's no special compilation is needed. It just follows the same workflow as you're developing and building for your real hardware. And in here, what we're trying to illustrate is these are the hardware platform that you are building your code to run on, and with your choice of operating system. And inside the simulation is Windows or Linux. And then the Simics environment together with Python support, we allowed you to take the same binary and perform functional tests for your software. We are not here to say that you can do everything, all the testing on a simulator. A simulator is to give you another perspective to look into how your code is running in a more convenient environment. From our experience with our customers from aerospace and defense, on average, we're talking about 60 to 80% of the tests can be run on a simulator, and there are still tests that is more relevant to run on the real hardware. So simulator is not here to remove the need of testing on real hardware. You still need real hardware to test timing critical functionality or hardware implementation specific functionality. But what we are saying is, using a simulator, using functional tests, there are a lot you can be done on a more convenient environment to do testing. So just want to summarize that there are 8 popular Simics system level features. For example, about scalability, and you can mix technology inside the simulation. It's supporting scripting underneath Simics using Python. And one thing that I want to highlight in here is about fault injection. And so in a simulator, which differentiate from an emulator is the ability of control and inject different fault conditions inside a simulation. You can create single event upset very easily in a simulator, and you can corrupt the memory and test how your software is going to react to it. And Simics is built modular and extendable, so it's a platform to allow you to extend the functionality and create the tests and modules that you need to run the test that you cares about. And then there are also another 8 popular Simics debug level feature. For example, it can synchronously stop the whole system. So imagine you have got 3 different boards that is running at the same time. By a press of button, all the board can stop, and then you can inspect at anything inside the simulation. There are also powerful breakpoints that you can set up in a multi-target situation. And more importantly, it's about determinism, we said, which means that if we can record and replay a debug. So if you see a bug in one of the tests, then what you can do is you can replay the test many times you like, so that you can find the bug that is difficult to check on real hardware, so that you can debug faster. And in some cases, our simulation, you can also reverse execute your code in order to understand the symptoms and also how it manifests itself into a crash condition. Last but not least, it's all about collaboration. Software is teamwork. So with a deterministic simulation platform, it helps developer to communicate the intent of the system and also to demonstrate how the system works. It's trying to remove situation that it works on my hardware and it doesn't work on someone else's hardware, because it's virtualized. You can create the hardware in many times as you like using simulation. So now I've gone into the demonstration. So I prepared 3 different demonstrations for you, depending on the time, to see whether I can go through all of them all together. It's a live demonstration and from a product manager and remotely as well. So hopefully, let's play. Let's pray that everything works for this demonstration. So first of all, I want to show you how Simics launch a fully managed virtual platform and boot an operating system, and then showing you how to control using script of how to control and interact with this virtual platform autonomously. And last but not least is to show you how simulation can be integrated into a regression test in a DevOps pipeline. Okay. So, before going into that, something I've learned there's a common question that can simulation run faster than real time? The answer is yes and no. It depends on what your whole system is like. For example, at the moment, I'm running WebEx, and the camera is capturing my images, and then it's recording. But at the same time, I'm also running Simics simulation. So it depends on the workload. It depends on I/O activity. On here is some data that I captured last night booting VxWorks. Unit processor on the left-hand side, we can see that the slowdown is 0.59, which means that 1 second of virtual time simulation takes in real time 0.59 of a second, so which is faster than real time, and we can see that it's executing 420 million of instruction per second. And on the right-hand side is we configured a VxWorks 7 in SMP mode. So in here, one second of virtual time actually takes in real time 1.47 seconds. So it's slower than real time, but it's executing more instruction. It's executing 552 million instruction per second. Okay, so let me bring in the Simics environment, which I have at the background here, and let me just clear the screen so that a little bit clear to see. This is the Simics environment, which is Eclipse-based. We can see that on the top left-hand side here, I have got the Simics project, which I've set up for today, GR740 user day. And in this Simics project, we have got target. And these are all the targets that is available for me to use to create simulation. And surprise, surprise, there is the Leon 4. And if I say click on the VxWorks 7 script, and I click on run, then it will bring me up a simulation with a 0 port here. And what I'm trying to show you is the benchmark that I've showed you earlier. So in Simics, we have got a command line interface, and I now set up to run a system performance meter, and it takes sample on 0.1 of a second of virtual time slice. And if I run 4-second simulation, what we see here very quickly is VxWorks7 is booted. So is well, it actually booted used the bootloader first from Cobham Geisler, and then it loads VxWorks7, and then it booted. So what we see here is the impact of my live presentation and live demonstration that impacts my simulation performance. So it's executing around about 300 million instructions per second at 4 seconds of virtual time simulation takes 3.34 seconds in real time, which is slowdown of 0.83. So this is just want to show you live how this is working with the impact of all the other things that is happening on my laptop at the moment, and booting a real-time operating system from us. Okay, so we can interact with the target as we want to. Okay, and if I terminate that, and I want to show you, so you might have question is how about non-VX work? How does it work then? So if I launch another simulation, and I've prepared a Altem binary. So so what I'm doing in here is commanding Simics to load an Altem Hello World application and into the memory. And then what I can do is I can, for example, examine the program counter of the processor, and I can change the output so that I can see where the program counter is setting up to. So at the moment it's pointing to this C000 address, and I can issue commands such as looking at the memory map of this GR740 design. So this is the memory map, and I can see that the program counter actually is pointing to the PROM at the moment. Okay, so however, this Hello World example seems like you have got an entry address at 0. So what I need to do now is to force the CPU. So now I'm doing some Simics magic to force the program counter on the CPU to point to the start of my Hello World address, which is 0. Okay, so if I run now, and I can pay attention on here, I got my Hello World from the Altem example. Okay, so let me try another example from Altem again. And this time, I would like to load the shell. And then I need to set the program counter to 0 again, and then run. If you're interested in the system performance, let me do that. So you can see it live, how fast it's running, and then I can interact with the example shell, just like I have got a board in front of me. Okay. And all these commands, actually, you can you can put inside a script. So in here, I've prepared an example. So like what I did earlier, I can run the GR740 setup, load the binary, set the program counter, and then run the test. And all these can be described, captured in a simple text file, and then all you need to do is just hit run. And Simics will execute the command for you by using this console input. There are more functionality or more complex functionality you can specify in this Simics environment to create your own automated tests. Okay. Right. So. And then very quickly, I know I'm running short of time, so maybe I wouldn't go through everything in this demonstration. In here, I've recorded a demonstration showing that in a Linux environment, we can use some script. And in this script, these are the Spark Leon 4 GR740 binary, and we can run all these in the command line. You can see that the VxWorks is booted just from the command line. There's no graphical user interface because we want to enable all these in a server environment. We can see that these booting the whole operating system and including launching Simics takes 1.7 of a second. And we can capture all these tests and examine different memory location all inside the Simics environment. And there are also test recording as well for how the simulation have been run. We can put all these scripts into a GitLab repo and create a Jenkins jobs to run it automatically, and archiving the test outcome and test recording afterward. So if we build, then what we see is it execute all the code, booting the operating system by itself, and we can specify the test that we want it to run, for example, checking a certain memory location 1, 2, 3, 4, and then adding another test which checks the version of the operating systems. And all these are now available on a CI/CD pipeline. Okay, so apologies, I couldn't show the everything in such a short period of time, but hopefully it gives you a flavor of how simulation can help in terms of making tests more available for developer to do application development and testing. And if you are curious enough, these are some links. And oh, by the way, we also have a YouTube channel as well. So welcome to have a look and give us a thumbs up if you enjoy some of these videos. And more, if you're even more curious, then get in touch. We are more than happy to answer any question. Thank you very much.